This one, let's take a look at some exercises on parabolas. We'll take a look at first analyzing a parabola, and then we'll also take a look at applying parabolas, a fencing problem, but also a physics question. Okay, so let's get going here. So this says, consider the quadratic function y equals x squared plus 4x plus 3. Coordinates of the vertex. We're beginning with that basic fact. So what you need for that is the x-coordinate of the vertex. That looks like basically negative b over 2a. You just need to identify a. So a is 1 here and b is 4. So a is 1 because in the front of that x squared is really like a 1 in this position. Let me put it right here, you see? That's a 1. So then you just plug into this formula. So I'm going to have negative, and in our case b is 4, so I'm going to have negative 4 divided by 2 times the value of a, which is 1. So you end up with negative 4 divided by 2, which is then negative 2. So that's the x-coordinate of the vertex. Let me write this down. So x-coordinate this way. Now that that's in place, let's find the y-coordinate of the vertex. So you just have to evaluate the expression at negative 2. So y, coordinate of vertex, in other words, like this, if you were to write it out, it's going to be negative 2 squared like this, okay, and then plus 4 times negative 2, and then plus 3 this way. And then you work through that, so 4 minus 8 plus 3. Hit that with PEMDAS, that's negative 4 plus 3, like this down below here. So we lastly then get that this is equal to negative 4 plus 3, which is negative 1. So our point would be the following, negative 2, comma, negative 1. Then it says the coordinates of the y-intercept. So to get the coordinate of the y-intercept, the coordinates, just replace x with 0. So in other words, when x has the value 0, that's when you get the y-intercept. So you're going to do the following here. Y is equal to 0 squared plus 4 times 0 plus 3. So it's going to be here basically 0 plus 3, which is 3. So the coordinates then would be the following, 0, comma 3. So x is 0 and the y-coordinate is positive 3, this way. Then it says coordinates of the x-intercept separated by commas as necessary. So to do that, you have to remember, what does it mean to be an x-intercept? Is where you're crossing the x-axis. So you're going to say the following. You take your x squared plus 4x plus 3 and set that equal to 0. Then you solve this equation, however you choose to do that. Here you can get away very likely with factoring. Let's see. So we need two numbers that multiply to 3, same two numbers add up to 4. So you can probably guess, but it would be 1 and 3 like this, right? Take a look. So 3 times 1 is 3, and then 1 plus 3 is 4. So these are the correct values, and x is the variable. So now you have two linear equations you can set equal to 0. So x plus 1 is equal to 0 is one equation. The other one is x plus 3 is equal to 0. So from this one, just subtract 1. So x will be equal to negative 1. And from this one, subtract 3. So x will be equal to negative 3. In terms of points, the points would look like this here, okay? These are just the x-coordinates. So the points would be negative 1, 0. That 0 has to be present because we're saying it says the x-intercepts. Remember, at the x-intercept, the y-coordinate is always equal to 0. So that's where the 0 is coming from. Right, and the other one then would be negative 3, comma 0. Again, at x equals negative 3, the y-coordinate is equal to 0. That's what it's saying. Right, for the domain, it's a parabola and it's not an applied problem. So that means that the domain is always basically this. It's negative infinity through positive infinity this way, right here. Now the range is a little bit of a different story. You see, look at this parabola. It's positive up here, positive 1x squared plus 4x plus 3. It's a parabola that opens up because 1 is a positive number, okay? So let me write this down. But let me just move my pictures around so I have more room here, 1 sec, so I can fit things better, okay? Like for this one, for the range. So notice we have 1, which is greater than 0, right? This one is the value of a. A is the coefficient on the x squared, right here. Okay, so it says 1x squared plus 4x plus 3. So that's greater than 0, which means the parabola, opens up. The way to imagine that is imagine like a cupped hand. That's a parabola opening up, you see? All right. Since that's the case, then the vertex is the lowest point, since the parabola opens up. And since that's the case, and the vertex is the lowest point, then the y-coordinate, so y-coordinate is the lowest y-coordinate, like this. So with putting all of that information together, you're going to have the following. Parabola opens up. There's a y-coordinate vertex here. It's the lowest. So you're going to go as follows. You're going to go basically from let's see, you have to be careful now. Where were we? So you see down here, or up here rather, let me point to it right here, right? We found that this value is -1, the coordinates of the vertex. The y coordinate is -1. So that means you're going to make use of that here. You're going to put -1, comma, positive infinity, and then close this way. And now lastly, let's make a picture. So let's make a picture using this information that we have gathered. Let's do that. So I'm going to do the following then. I'm going to make some points. Alright, so here's a point. Where do I put this point? I mean, you have all of this information gathered. We want to make use of it, right? So you can, for example, put a point at -1, 0. Put a point at the X-Intercepts. So -1, let's see, where are we here? So that's right here. Okay, I'm going to make that one green so you can see it, you see? Alright. Put another point at -3, 0. So again, I'm going to make that green so we can see it. -3, 0 is right here. Okay, mark the vertex. Remember, the vertex has the coordinates -2, comma, -1. So I'm going to make that one say red so we can see it. Alright, let's see here. So -2, -1. Okay, it kind of looks like this basically. -2, -1. Remember, there's also the concept of an axis of symmetry. So here the axis of symmetry, let's make that on the bottom of our last question. So axis of symmetry is, remember by definition, x coordinate of vertex. You just write it as x equals, for example, -2 in this case. So you can draw basically the following to this graph. Let me do that right now. I'll do that one in blue. Okay, so you draw an axis in a picture like this, you see? That's your axis of symmetry right there. Why is that useful? Because once you have it, then you know how to place your points, you see? And also remember we have the Y-intercepts, that's at the point 0, 3. So let me add one last point here, Y-intercept. Let's see, I'm going to make that point also say gray. I'll make it gray. So go over to 0, 3, that's right here, see? So we have the vertex placed, we have the two roots or X-intercepts placed, and then we have the Y-intercept placed. Now by the axis of symmetry, take a look, okay? So this is, right, this right here, this separation is 2 units right there, okay? From the axis of symmetry to the Y-intercept is 2 units. Which means on the other side of it, there's also a point, mirrored to the other side of the axis of symmetry. Like this, in this position. And you want to know that because now you can complete the picture pretty well. Okay, so I'm going to try to freehand this to the best of my ability on a computer, but it's going to kind of look like the following, you see? Like this, and then like this, and then like this. There you go. So that's an example of analyzing a parabola and writing down all of the relevant facts and then making a graph based on the relevant facts. Alright, so now we're back at this one. A gardener has 120 feet of fencing to fence in a rectangular garden. One side of the garden is bordered by a river, and so it does not need fencing. Here's a picture. What dimensions would guarantee that the garden has the greatest possible area around all answers to the nearest whole number, for example? Okay. So let's go through the process a little bit. What you can do is you can label things. Let me disable that for a second. Okay, so label things. Call, for example, this X and call this Y. And call this X because it's the same thing. Remember, back here along the river, we don't need fencing because the river functions as a natural fence. Okay, so then write down some equations. So first of all, the perimeter. So perimeter, or the fencing if you like, that would be equal to X plus X because this is an X on the left and the right, and the right, and then a Y from the bottom. And then you simplify this expression, so it's going to be 2X plus Y this way. Okay. Now, we are told that this is equal to 920 feet because, you know, the farmer or gardener went and bought that. So you take this 2x plus y and you set that equal to the 920 this way. One fact. The other fact is the area is equal to the following. So area is equal to xy. You just multiply the vertical dimension, whatever you call it, by the horizontal dimension. The fact that the vertical is called x and the horizontal is called y irrelevant. You could have just as easily called the vertical parts x, well, y, and then you could have just as easily called the horizontal part x. Just call them something. You can even call this v for vertical and h for horizontal. Okay, we just use x and y from conventional purposes. Anyway, so we have area is equal to xy. Now, take a look. It says we're going to make a function that represents the area only in terms of x. So you're going to write a of x, like this. And then how do you make that function? Well, you have this 2x plus y equals 920, and the area is also xy. So you want to, in the perimeter here, in that equation, solve for y. So you can do that simply by writing that y would be equal to 920 minus 2x. I'm just taking the 2x, I'm subtracting it from the 920, and that's it. And now, this y right here, an expression that represents the area, that y can be replaced with 920 minus 2x. So you're going to end up with x times 920 minus 2x this way. And now you have the area enclosed by the fencing given only in terms of the variable x and nothing else. Look at the questions. We want to find the shortest side, we want to find the longer side, we want to find the greatest possible area. From here, I'm going to work on this down below here. It's going to be a bit of a... Okay, so a of x would be equal to the following. Take this x and distribute it, so it's going to be 920x minus 2x squared this way. And now, remember, this is a parabola, right? Because it's negative 2x squared. If you like, write it this way. So you have here negative 2x squared plus 920x. All right, and then identify. So a is negative 2 and b is 920 and c here is equal to 0, for example. There's no term at the end. All right, plug this in to the following. Negative b over 2a. All right, you're going to look at the vertex of the parabola. We have the information identified. All right, so it's going to be here then. So negative 920 divided by 2 times negative 2. So it's going to be negative 920. Oops. Yeah, negative 920. Okay, let me highlight that the right way. Divided by negative 4. You punch that in. And this tells you 230 right here. So that's 230. That's the x-coordinate of the vertex, 230. Now that we know the x-coordinate of the vertex, we can find the y-coordinate of the vertex. How do we find it? Remember, up there we solved for y. So we had y was equal to 920 minus 2x, right? So then you just use this. You're going to do 920 minus 2 times 230. And you worked with this, so it's going to be here 920 minus, right, so it's going to be 460. You punch this into your calculator, and that gives a value of 460 right here. Okay, so 460. That's the longer side. Just like the 230 is the shorter side. So that's how we get these answers right here, right? We got 230 here, and then we also got 460 in this position by using this approach. Now let's find the greatest possible area. So that means you evaluate the function at 230 this way. So I'm going to have 920 times 230 minus 2 times 230 squared, and then you work through this. Okay, in practice, numbers get big, or they get, have a lot of decimals, they get messy. So this thing is 211,600 minus the 2, right? Then you're going to square here the 230. So that's going to give you that number right there, 52,900. And then punch this thing into the calculator. And you're going to have a value here of 105,800. So that's the maximum area, basically. So 105 and then 800. There you go. Okay, so this part is done. The last question, let's see what it says here. An object is thrown upward at a speed of 148 feet per second by a machine from a height of 8 feet off the ground. The height h of the object after 2 seconds can be found using this equation here. When will the height be 268 feet? So basically what this is saying is take h and set it equal to 268 and solve that equation. So in other words, solve this equation. Negative 16t squared plus 148t plus 8 is equal to 268. Okay, so again, in practice, as I'm sure you know by now, things get a bit messy with the numbers and all that. So try to simplify this any way that you can, dividing a common factor out as much as possible. So let's see. Let me just experiment a little bit, right? Is 148, it would be nice, right, if it were divisible by 16 this way. Okay, it's not really, you see, because it's 9.25, so it's not good. Okay, so maybe try to divide by like 8, a factor, 18.5. Right, try to divide by 4, a factor. Okay, that's 37. There you go. So I'm showing you the different ways to think about this. So this is 37. So I'm just going to divide probably everything by 4. Take 268. Let's see. Is this divisible by 4? Okay, so let's see. That's 67. Right? That's smaller. That's better, right? And the 8 and the negative 16 each is already divisible by 4. So divide the whole equation by 4 first. That will make it simpler. So negative 16 divided by 4 is negative 4t squared, okay? All right, we've already seen just now that 148 divided by 4 is 37. 8 divided by 4 is 2, and then 268 divided by 4 is 67. Equation is simpler already, okay? So now gather everything on one side. So negative 4t squared plus 37t plus 2 minus 67 is equal to 0. Okay, so negative 4t plus 37, let's see, t, and then minus 65, okay, is equal to 0. Continue here. At this point, plug into the quadratic formula. We have some kind of messy equation. So it's going to be the following then. So t would be equal to negative b. So negative b in our case means 37. And here I meant to put a t squared right here. So that's 37. And then plus or minus the square root of b squared. So that's 37 squared. Minus 4 times a, which is negative 4. And then times c, which is negative 65. And you divide it by 2 over the value of a, which is negative 4. From here, in applications, often you just do this on a calculator because it's so messy. So let's see what we're going to get here. What does my calculator tell me? So I'm going to have t. If you like, you can at least separate it by the plus or minus. That might be a step that you can do. But let's see. I'm going to get from mine the following. It gives me 37 plus or minus 18.14 divided by 8. That's how my calculator simplifies that work. Now let's actually find each of these values independently. I'm going to do the 37 plus the 18.14 divided by 8. That's one of these values. All right, so when I do that, it's going to give me 6.89. And the other one will be t is equal to 37 minus 18.14 divided by 8. You punch this into your calculator. All right, and you're going to get here 2.36. So there are two separate values. In other words, as you can see up here, right? 2.36 seconds into the process and 6.89 seconds into the process is when this object is at a height of 268 feet. That's what those numbers mean. Now the last part says the following then. When will the object reach the ground? In other words, that means when will h have the value 0? Go back and look at the equation for a second right here. See, the equation states the object is an 8 in this position. That means that the 8 tells you the initial height of the object when it's first launched. It's launched at 8 units, okay? So then we look for the second time when it strikes the ground. So you're going to have h is equal to 0. You need to solve that equation. All right, and then I'm going to have the following. Negative 16t squared plus 148t plus 8 is equal to 0. As we've seen already, we can divide each term by 4. So negative 16 divided by 4 is negative 4t squared. 148 divided by 4 is 37t, and then 8 divided by 4 is 2 is equal to 0. So it's a simplified equation here. Okay, and now the difference is just plug into the quadratic formula. Remember, that means a is negative 4b is 37, right? And then c is 2. It's in that form. So like ax squared plus bx plus c is equal to 0. It's got to be that form. So I'm going to have the following then. So t will be equal to negative b, so that's negative 37 plus or minus the square root of 37 squared minus 4 times a, which is negative 4, times the value of c, which is 2. And you're going to divide that by 2 times the value of a, which is negative 4. As before, this is calculator work. It's going to get messy. So do it on your calculator. In my case, my calculator gives me 37 plus or minus 37.43 divided by 8. Separate these into separate answers. Okay, let me do that right now. So in other words, 1t will be 37 plus 37.43 divided by 8. So punch this again into your calculator. I'm taking the one with the plus here. Okay, so that gives you 930. And that's the one that we want. And then the other t, it seems like there's another t there, so let's find it. 37 minus 37.43, and this is divided by 8. All right, and you punch this into your calculator, and that gives you a value that's negative right here, see? Negative 0.054, and then you ask yourself, that's strange. All that this number is saying is if you kick the ball, or whatever the object is, if you launched it about, that number of seconds before you did, it would be the same as if you were launching it from ground level. That's the way to think about it, you see? So that value can be interpreted. That's all I want to say. I hope this video is helpful, friends. It concerns a lot of facts, as you can see, on parabolas, not just analyzing them in a mathematical fashion, but also applying them in a couple different ways. So that is it for this one, friends. Please leave a like, please subscribe. Thank you so much for watching. I hope it was helpful. I'll see you in the next video.